Hello, welcome back. We're going to start into section 4.4 now. We worked a few kinks out in the video recording, so this will be a little different format. We'll see how it works rather than PowerPoint. What I want to do in this video is tell you a little bit about Kramer's rule. It's one of those things that you often skip over in linear algebra, but it's a really slick way of solving a system of equations, and it will be particularly helpful in this section. Otherwise, the algebra just gets absolutely hideous. So we're going to do it in the algebra sense for this one. And suppose we want to solve 3x plus 2y is 7 and 5x minus y is 12. Of course, you have your basic methods of elimination substitution available. But what you'll find is you end up getting some nasty fractions when you do that. Kramer's rule is a trick that allows us to solve without the messy algebra. So let's go over what Kramer's rule is. First of all, it basically goes through and it solves the system using determinants. And if you notice, the solution for each of these, the denominator is simply the determinant of the original coefficient matrix. And that makes sense because if the determinant of the coefficients is 0, it would not have a solution. And that, of course, would cause us to have undefined values here. Since in this case, the determinant's not 0, it means it has a unique solution, and we can find it. To find the x, we simply replace the x column in the determinant with the solution vector. So the 7, 12 goes in place of the 5, 3. And then we simply compute that. And so you get x is 31/13. Notice, even though the answer is fractional, we really didn't have to do any fraction computations along the way here. Y in this case would be our, again, same denominator of 13, negative 13. And then we replace the y column with the 7, 12. And we get negative 1/13. So this is just another way of solving systems of equations that doesn't involve messy algebra. Again, it's in the linear algebra text, but it's one of those sections that gets skipped over. So if you want to, you can most certainly look up why it works. The nice thing, though, is you don't have to know why. It's very easy to use. Okay, well, let's move on to a 3x3 example here. So again, we have our system of 3 equations and 3 unknowns. So x plus 2y minus 3z is 1. X minus y plus 5z is negative 3, and 3x plus y minus z is 4. Again, you could use your traditional elimination and so on, but this particular method is going to be especially suited to what we're going to do in the section of differential equations. So again, our denominator, we put the coefficient matrix in there. Now, again, evaluating 3x3 determinants is a little more messy. And so when you go through all the cranking through, you get 9/5 for x. Notice, though, the denominator before reducing was a 15. And that denominator is going to be the same for all 3. So we really don't have to recompute that bottom determinant. So notice we just put the 15 down there and then recompute the numerators to get y is negative 8/3. And z is negative 23/15. Okay, that's all I wanted to do for Kramer's rule. Again, this is just a tool we're going to want to use in this next section, but I thought it'd be good to go over it in a short little video here. So later you can expect me to upload 4.4, and I'll include what should have been last Friday's story with that one. I hope everything's going well for you, and take care.